Okay, so I thought I'd walk through this walk through this exercise a little bit. So let's look at those two original, see, where's my pointer here? Let's look at those two original functions. Okay, so here's g of x, and we know we can't divide by 0. So we set that denominator equal to 0. If we add 2 and then take the square root, we get two answers, right? Negative square root of 2 and positive square root of 2. So those two values are not in the domain of g of x. So we got to keep that in mind. And then for f of x, we can't take the square root of a negative number. So we're going to solve this inequality. 4 minus x to be greater than or equal to 0. And if you subtract 4 and divide by -1, you get to reverse the sign in the direction of the inequality, right? So x has to be less than or equal to positive 4. So those two domain limitations never go away. Even if we do the composite and algebraically some of it disappears, we still need to consider those, okay? And I'll show you why here in a minute. So then let's do the composite function, g of f of x. So I replaced, in this function, every place I saw an x, I replaced it with the square root of 4 minus x. And of course, if we square root, it disappears. And then 4 minus 2 is positive 2. So that's the composite function. And if we look at this one, we know that x can't be equal to 2 because, you know, if you set the denominator equal to 0, all right? So it looks like x just can't be, so negative infinity to 2, we'll skip over 2 and 2 to infinity, right? But what about, remember these original domain limitations? If according to this, I can find g of f of 5. But if I try to find that in the original functions, right, so I drop 5 in for x, 4 minus 5 is -1. I can't take the square root of -1. So I couldn't find g of f of 5 back in the original functions. Those domain limitations do not disappear. So that says that original domain limitation of x has to be less than or equal to 4 is still in play. We haven't gotten rid of that. And then how about the square root of 2 and negative square root of 2? So what we got to worry about, because we're evaluating this first for the square root of 2, right? Okay, and then we're evaluating this. We're looking for where is this equal to the square root of 2? Well, let's see. So I said, where does that original f of x function equal the square root of 2? So I squared both sides. I made a mistake here. All right, so I'm going to subtract 4. Oh, let's do this. I made a mistake. It's going to work out the same, but I see an error. They happen. Good thing I'm checking my work. So that's going to become, so that's not right. That's going to become negative x equals -2. So x equals 2. And we've already ruled out x equals 2 in our composite. So this function, even though it equals 2, it's ruled out. So that doesn't limit the domain anymore. How about negative x squared, negative 2x squared? Well, with that one, the result of a square root function, right? The square root of 4 minus x is always positive, so we'll never get a negative square root of 2. So that's never going to be equal to root 2. So that's not a problem of composition. So I think, remember that 4, what we're going to do is go from negative infinity until 2, skip over 2, and then we're going to stop it at 4 because of that original domain limitation. So that's algebraic. How can we approach this graphically too? Well, let's see. If you let me come over here. And where's Desmos here? This is a tool. If you've never used Desmos for this, it's really great. So the way you can get a function here, let me clear that writing. The way you can get Desmos to graph a composite function is writing your two functions individually. And when you got to label these like f of x and g of x, you can't just use y for both because that'll confuse the system. But then I do want to have a graph y. So notice what I did is is I typed in those two original functions, but I turned them off so they aren't getting graphed. And then I said down here in the third equation, y equals g of f of x. And I actually wrote the composite, and see what we're seeing right here is the graph. Notice the function stops at 4, right? It includes 4. If you go back and look at that, I erased the drawing, but actually I think it's on the original one. See how I included 4? And I just skipped over 2, and we can see the skipping over 2 by seeing, let's come back to it. See that break in the graph, vertical asymptote, maybe you know from earlier coursework, is that vertical. So when x skips over 2, and then it is defined. And then what I did with these things here, I was exploring the square root of -2. Well, that's got a value, that's not undefined. And the same thing with +2, that's got a value, that's not undefined. Okay, so that's one way you can do some exploration, and then I want you to support it graphically, or I mean algebraically. Okay, so that's that question. I'll stop this video and get it uploaded.